Okay, now we are in solving systems by reducing matrices. Solving system by reducing matrices. Okay, so we are given this system of equation. We want to solve it by matrix reduction. Okay, so I write that system again. Write the system again. 2x plus 3y equals to -1, then 2x plus y equals to 5, and x plus 1 equals to 1. Okay, x plus y equals to 1. So this is the system. The first thing to write is to write the augmented matrix. Okay, to write the augmented matrix. But let me first write like this. Our coefficient matrix from here is 2, 3, 2, 1, 1, 1. That's our coefficient matrix. Okay, our matrix X in this case is X and Y. Okay, don't forget it's not X1, it's not X2, it's X and Y. So you follow what is given. And then our right hand side, our coefficient at the right hand side is -1, 5, and 1. Okay, that is the coefficient at the right hand side. Okay, so our augmented matrix, coefficient matrix, our augmented coefficient matrix is the combination of these two, is the combination of those two. Okay, so we now have 2, 2, 1, 3, 1, 1. Then we put a line there, -1, 5, 1. Okay, so that is our augmented matrix. That is our augmented matrix. Okay, so we now work on this augmented matrix. We need to work on the augmented matrix to be able to find what we need to do and to reduce it. Okay, so let's reduce this. To reduce this, the first thing is that we need this to be 1. We need this to be 1. Okay, don't forget our rule. We can interchange rule. Can interchange one row to another one. We can multiply a row by a number. We can multiply a row by a number and add it to another row. Okay, those are our rules. So if I call this one row 1, of course it is row 2, and then this is row 3. Okay, you don't need to show that, or you don't need to put that, but that is what I'm going to be making use of. Okay, please take note. This is row 1, this is row 2, this is row 3. All right, so the first thing is to make this a leading one. Make this a leading one. Okay, to make it a leading one, I can either interchange row 3 with row 1, or I just divide row 1 by 2 so that I can get a 1 there. I think I will go by that so that you be able to follow me. Okay, so I divide this, so I mean 1 over 2 row 1. So I'm dividing this by 1. I'm using this to find the formula to write or the expression to use. But I'm going to perform this operation for all the elements in that row. So I said 1 over 2 row 1, then I'm giving it to row 1. This is very important. Please, whenever you write the formula, you must tell us where you are giving it. I'm giving it to row 1. So if I do like that, the resulting matrix will be 1. I'm dividing this by 2. I'm dividing it by 2. And then I'm dividing this by 2. Okay. The other one remain the same. They are not changing. They are not changing. They are not changing. Okay. That is the first one. Now what is the next one? Don't forget, I'm reducing this matrix. This now supposed to be 2 after 0. After a leading 1, every element in that column must be 0 after a leading 1. So this supposed to be, I need to make this to be 0. I need to make this to be 0. Okay. I need to make this to be 0. I need to make this to be 0. So what formula should I use? This is row 2. I'm making row 2 to be 0. So I will say row 2 minus 2 row 1. Row 2 minus 2. So please take note, the row you are changing must not be negative, must not carry that negative. So I'm giving it back to row 2. The row you are changing should not have that negative. So don't write like this, 2 row 1 minus row 2. This is row 2 you are changing. So please don't let that row carries the negative. Okay, so please take note of that. All right, so that is how to change row 2. This will become 0 now. Now I can also write the formula for row 3. So row 3 minus row 1. So I'm using this minus this, and I'm giving it to row 3. I'm giving it to row 3. Okay, let's perform that operation and see what are we going to get from there, what we are going to get from there. This remains the same. That is not changing. That one is not changing. Okay, now I said row 2 minus 2 row 1. Row 2 minus 2 row 1. This obviously will be 0. Row 2 minus 2 row 1. That means 1 minus 2 times 3 over 2. So that means 1 minus 3, that is minus 2. Okay, row 2, 5 minus 2 row 1 times minus 1 over 2. Okay, that will give us 5 plus 1, which is 6. Okay, this will be 6. Now let's go to row 3. Row 3 minus row 1. 1 minus 1, obviously 0. 1 minus 3, 1 minus 3 over 2. This is same thing as 2 over 2 minus 3 over 2. And this is 1 minus 1 over 2. Okay, that's fine. Now, 1 minus 1 over 2. Okay, that is minus 1 over 2. That's what I've done here. So, but this one is 1 minus 1 over 2. So 1 minus 1 over 2 will give us 1 plus 1 over 2, which is 3 over 2. Okay, so this is 3 over 2. All right, so now I've made a leading 1, and I've also made the other element in that column of a leading 1 to be 0. What is the next thing to do? The next thing to do is to also make this a leading 1 to the right. A leading 1 to the right. So I need to make this a leading 1. All right. So to make this a leading 1, I'm now dividing row 2 minus 1 over 2 row 2. So I'm dividing row 2 by minus 1 over 2, and I'm giving it to row 2. Please take note of that. I'm giving it to row 2. All right. So what will be the answer of that? This is not changing. That one is not changing. This also is not changing. This also is not changing. Okay, this is the only thing that's changing. This divided by half is still 0. This divided by minus 1 over 2 is 1. This divided by minus this is minus 3. Okay, that is fine. Now what is the next to do? The next to do is to make this a leading 1. This must be 0. This also must be 0. Okay, so let's do and see what we need, the formula that we need. So in order to make this one 0, we say we are changing row 1. So it will be row 1 minus 3 over 2 row 2. Okay, minus 3 over 2 row 2. Then I'm giving it to row 1. Okay, in order to change this to 0, this is a negative already. So I will say row 3 plus now plus 1 over 2 row 2. And then I am giving it to row 3. All right. So now let's find the matrix of that. What is the matrix of that? Row 2 is not changing. Row 2 is not changing. So I leave it like that. All right, so row 1, when it changes, it's row 1 minus 3 over 2, row 2. Row 1 minus 3 over 2, this is 0. Row 1, 3 over 2 minus 3 over 2, row 2. 3 over 2 times 1. Okay, that is 0. Row 1 minus 1 over 2 minus 3 over 2, row 2 minus 3. Okay, that will give us minus 1 over 2 plus 9 over 2. And that gives us 8 over 2, which is equal to 4. So this is 4. All right. So let's do row 3 now. Row 3 plus half of row 2. Half of row 2, that is 0. Row 3, which is minus half, minus 1 over 2. Please keep all this calculation by the back of your paper or by one side of your paper. Don't let those calculations be cloud your workings. Okay, so we have here minus half plus 1 over 2 multiplied by row 2 multiplied by row 1. Okay, multiplied by 1, so this is 0. Okay, this is obviously 0. Okay, now this last one, that means row 3 plus 1 over 2 row 2. What is in row 2 minus negative 3 multiplied by negative 3? That will be 3 over 2 minus 3 over 2. Okay, that is 0. So this is 0. All right. So now, oh, sorry, this is supposed to be 1. This one supposed to be 1 is our leading one there. So it's supposed to be 1. This is supposed to be 1. Okay, fine. So now we have this in a reduced matrix. It is now in a reduced matrix. Now, if you look at what we have before, we make this to be in this form. If you look at this column is for x. They are all x, 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 x. Okay, this is 2x, 2x, 1x. So this column is for x, while this column is for y. Okay, so in our reduced matrix, this column is for x, this column is for y. Okay, we see x is 1 here, so we now have x times 1 equals to 4, which is x equals to 4. Okay, so we have x equals to 4. We have x equals to 4. Also y, it will be y equals to negative 3. So we have x equals to 4 and y equals to negative 3. You see, from our reduced matrix, we can easily pick the value of x and the value of y. That's why we are reducing it. We are reducing the matrix so that we can easily find our value of x and y. If it is up to z, then it will be x, y, z. If you are given in terms of x1, x2, x3, then we will pick the value. X1 equals to something, x2 equals to something, then x3 equals to something. So that is why we are reducing the matrices to be able to solve for our x and y. Okay, please ensure that you understand